Hello, my name is Jackson Nestler, and I'm here to talk about my student innovation project named SpookySOC, a scarily good toolkit for security analysts. Before we begin, ask yourself, how long might it take one of your security analysts to perform open source intelligence on a single observable, a single hash, host name, domain, etc.? Do you have a number in mind? Great. Based upon our testing and our interviews, it seems that this can take anywhere between 6.5 to 14 minutes, depending upon the information readily available for this observable. This is where SpookySOC comes in. SpookySOC aims to take all of your observables for a case, run them through free threat intelligence scanners, reputation databases, etc., and return a meaningful output all in the span of 30 to 45 seconds. Perhaps the best part about SpookySOC is that it has been written with the goal of open source in mind from day one. The entire code repository is available on Git Lab for anyone to use under the GNU AGPL version 3 license. At present, SpookySOC can take 3 kinds of observables: IP addresses, domain names, and hashes. These are all run through open source intelligence feeds, as can be seen here with an IP address, and return output that immediately gets the analyst's attention through color coding, as well as a copy and pastable format that can be embedded straight into your ticketing platform. Each observable type goes through several intelligence feeds, including VirusTotal, ThreatMiner, Hybrid Analysis, Shodan, and more. Where possible, we've combed through the APIs and returned only meaningful data. Gone are the days of JSON dumps being printed to your terminal. And here you have a wonderful example with VirusTotal explaining how many engines failed to analyze a hash, how many detected it as non-malicious, as well as the community reputation. Previously, this all would have had to have been found manually, browsing through the website, navigating through different tabs. Since SpookySOC is written in Python 3, it's incredibly easy to get up and running. You need to run a single command to install the requirements, which are included in the Git Lab repository. After this, you'll need to fill out your API keys. This is incredibly easy to do and uses only free API keys, though you can purchase premium API keys from the vendor, such as VirusTotal or Hybrid Analysis, to get a little bit more information. API keys are provided in a YAML file, laid out very simply as shown above. While these API keys are used for demonstration, they are free API keys. None of them are enterprise versions, so the output that you're seeing through these slides is what you can expect with a free API. However, investing in a premium API for services like VirusTotal may prove helpful for your open source intelligence. With the Python 3 implementation of SpookySOC, we're able to get running on any platform out of the box. macOS, Windows, and Ubuntu 20.04 have all been tested to allow analysts to be able to get up and running with minimal configuration, minimal downtime, and get to what's important, analyzing their observables and making a difference. Shown here is an example. You're able to take the SpookySOC output and put it directly into a ticketing platform. Using special characters like asterisks and escaping URLs allows you to paste this into your ticketing platform with no problems. You could send this straight off to a client and not have to worry about it being parsed incorrectly by their ticketing system. It gives them very easy access to your findings and allow them to reproduce. A project wiki is available on the Git Lab page, allowing you to get running with SpookySOC in right about 10 minutes. The most time-consuming part is signing up for the APIs. If you have an enterprise subscription, this is far quicker and easier. However, SpookySOC wants to be able to run with no cost associated. In the future, we plan to allow for users to supply a template and automatically generate a ticket output for their observables. We'd also like to add a GUI and integrate with MISP for threat intelligence, the Hive's Cortex for more in-depth analysis of observables, and more. This allows your analysts to spend less time finding information and more time protecting your customers. For project information, please see the GitLab repository linked above. The wiki is also available in the same GitLab repository, so you can get started today. And finally, you can keep track of our changes, upcoming plans, and more by viewing the changelog. Thank you for your time, Have a great rest of your day.